Hi everyone. The last section we will chat about in Chapter 8 is 8.3. I really disagree the way the book has ordered the sections. As you can tell, 8.3 is a very different way of thinking about square roots and radicals in general. I feel it really is better fit at the very end. So here we go in our conversation on 8.3 rational exponents, and you can see I've already circled the word ratio in the word rational. When we think a ratio, think a fraction, right? The ratio of the numerator to the denominator. So what is this all about? How are fractions connected with radicals? So it turns out that if you're taking the nth root of a, you can think of that as a raised to the 1 over n, where now that fraction 1 over n is the exponent. Pretty nifty idea. For example, 8 raised to the 1/3 is the same thing as the cube root of 8. And the cube root of 8, if that's more helpful to think of it this way, well, what times itself 3 times gets you 8, and the answer is 2. So if somebody wrote the cube root of 8, this means exactly the same thing. 8 raised to the 1/3 equals 2. Try that out in a calculator, and hopefully it should agree. I'll say that much. Which turns out to be a really much more convenient way of looking at numbers with, kind of non-obvious roots like fourth roots and cube roots. It's easier to put it into a calculator as a fraction exponent. They kind of make the features of the calculator that way. Anyway, okay, that's another kind of a side topic. So here we go. The nth root of a is a to the 1 over n. We can go a little bit further. What if we're also raising that a to another power, the nth root of a raised to the m? Turns out we can think of that as a raised to the m over n. For instance, I'm kind of showing you everything here at once, but if we did a raised to the 3 over 2, if you try that out in a scientific calculator, and I invite you to go ahead and do that and confirm this answer, that it will equal 27. Why would 9 raised to the 3 over 2, I mean, a fraction as the exponent? How bizarre. Well, what does that really mean? It means the square root of 9 to the third, right? The index of the square root is a 2. We don't write it there, but there it is. The 3 is this exponent over the index in the root, right? Just like here, m over n. So I see that 3 over 2, and I know the 3 goes there, and the index of my radical is a 2. And well, think of it this way. Well, 9 to the third is 729. If I take the square root, I'll get 27. There's like two things happening. Take it to the third power, but then also take the square root. And in this case, it's 27. So if you've got a more modern scientific calculator, you can type these exponents in, the fractions in, really easily. If you've got a slightly older calculator, you've got to be a bit careful. I happen to have an older calculator here to kind of demonstrate. So just for our two examples, an older calculator, you've got to use parentheses. So here, I don't have this, more modern, really nice kind of screen and user-friendly. I've got to use my caret button. I'll just show you everything. My caret button is down here, 8 caret. So if I want to do that first example of 8 raised to the 1/3, then I've got to be careful to use parentheses on my 1/3. And there it gives me the answer of 2. If I forget these parentheses, well, then it's thinking of it differently. It's not raising it to that whole thing. So be careful there. And then if we wanted to try the other one, again with a slightly older calculator, I've got to put the 3 over 2, 9 raised to the 3 over 2. That whole thing needs to be put in parentheses. And now it's thinking of it the way I want it to. 27. If we left the parentheses off, if we left the parentheses off, then that's not what we're looking for at all. That's taking 9 to the third, figuring that out, and then dividing that in half. But we don't want that. This is what we mean. You could even, in this case, right, you could say 9 raised to the 1.5. That would be the same thing. So be careful on your slightly older calculators. Use parentheses when you need them. Okay, so where are we going from here? We've really just introduced the idea. We're now going to look at examples. Before we do that, I want to remind us all the rules of exponents. Let me just kind of put those all out. The 7 rules of exponents, and they don't quite all fit on the screen at the same time. That's okay. Questions in this section are going to be exponent questions. You're going to see now fractional exponents. And the idea is, well, we just know what that means now and how it connects to radicals. But all of these rules will apply. So you might want to write these down again. Maybe you're more familiar with some than others. If we were in class, we would go through these one at a time, and I would have you guys tell me what each of them equals, right? We're multiplying there means we add. We're dividing this way, we subtract. Raise a power to a power means we multiply. And, we've gone through this conversation a couple times, I think, in the review and before we even started this chapter, because we had similar rules with radicals to numbers 4 and 5. Remember, anything raised to the 0 equals 1, and a negative exponent means you take the reciprocal, that you can flip it over and it will become positive. Okay, lastly, when we're given directions here in a moment, it's only going to say simplify. That's it. What does that mean? And there's some things that are implied. For one, in the end, when you simplify, every exponent needs to be positive. So if we started with any negative exponents, we need to flip those over, take the reciprocals. Each variable is written once. So maybe if at first x appears 2 or 3 times, we need to find a way to combine all of those into a single x raised to a power. In a lot of questions, there's more than one variable. So we have to combine all of each one. And finally, all constants with exponents are multiplied out. So like those first examples we were doing, 8 raised to the 1/3, we don't want to leave it that way. We want to figure out what is 8 raised to the 1/3. And we'd say, well, in that case, it's 2. So we'd want to simplify any numbers as well. Okay, so we've got our rules of exponents. We've got what does simplify mean. Let's dive into it. We'll do 1 or 2 of these, and then I'll show you one, and we'll have a second video on this as well, so we don't go too long. Okay, this is about as simple and straightforward as they get. X raised to the 7/6, all raised to the 8th. And simplify. Okay, well, which rule would apply here? And I can't put them on the screen at the same time, but I believe it was rule number 3. An exponent raised to an exponent, we need to multiply those. So I'm going to trust that you can do that multiplication in a calculator and simplify it. 7/6 times 8 would simplify to 28/3. There's our answer here, x raised to the 28/3. And that's it. Notice you don't have to rewrite it in a square root radical notation. Just apply the rules of exponents. There it is. I'm going to show you guys this one, and we'll take a break. So Try out part B on your own, and then when we come back, we'll look at it together. It's x raised to the 3 over 8, y raised to the 1/3, times x raised to the 7/10, y to the 1/4. Use a calculator to work with those fractions. The answer is in the next video. Good luck.